So in this problem, we need to determine the area of an equilateral triangle that is inscribed in a circle whose equation is given in its general form. Okay, so let's try to understand the problem graphically first. Let us suppose we have an equilateral triangle with vertices given by A, B, and C. So this equilateral triangle is inscribed in a circle whose center is O. Now, we need to find out the area of this particular equilateral triangle. So what we do that? In order to find out the area of the triangle, we'll need the length of the base, which is BC, and we'll also need the length of the altitude. So to find out the altitude, we'll join OA, and then from O, we're going to drop a perpendicular on BC. So that is going to be 90 degrees. Let's call it D. Fine. Now OA, that's going to be nothing but the radius of the circle. Similarly, if we join OB, so that's also going to be the radius of a circle. So using this information, let's try to find out first the length of the base and the length of the altitude. Fine. Now here we are given the general equation of a circle, which is x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Now, if we are given the general form, then the center is going to be having the coordinate given by negative g comma negative f, and the radius is given by r equals to negative g squared plus negative f squared plus minus c, or simply square root of g squared plus f squared minus c. So we have the information regarding the radius and the center. What we need here is to find out the length OD and the length of BD first. So for this, we're going to consider the right triangle. In right triangle ODB, which is right angle at D, we will try to find out the length BD and length OD. Now here we can observe that the angle BDO, so this is 90 degree, and since it's an equilateral triangle, then angle ABD, so that's going to be 60 degree. Now we know that the radius OB, it's going to bisect the angle. Since it's bisecting the angle, that means that angle OBD, this must be equals to 30 degree. So if this angle is 30 degree, then what must be the measure of angle ODB? So angle ODB, so that's going to be equals to 60 degree. And angle OBD, that's going to be equals to 30 degree. Now, we want to find out the value of OD. So let's use angle B. So if we take sine of angle OBD in triangle ODB, then the sine of that angle 30 degree is going to be defined as the length OD over the hypotenuse, which is OB. So that means we now have sine 30 degrees equals to OD, that's the length that we need, divided by the hypotenuse, which is a measure of r. The OD will be equals to r times sine 30 degree. And what's the value of sine 30 degree? That's half. So r value is going to be, so OD is going to be r over 2. So now we have the length of OD. Now that you have the length of OD, let's try to find out the length BD as well. So to find out the length BD, all we have to do is take cosine of angle OBD. So angle OBD, that will be the base BD divided by the hypotenuse, so that's r. So we have BD equals to r cosine 30 degree. So what's the value of cosine 30? We know that that's simply square root of 3 over 2. So our length BD becomes equals to square root of 3 over 2 times r. Now we are ready to find out the length of the hypotenuse and the base. Now we need the length of BC. BC is nothing but twice the length of BD. That's because we know for a fact that whenever we have a perpendicular from the center of a circle drawn to any of its chord, then it's going to bisect the chord. That means the length of BD is going to be exactly equals to DC. So since we have already obtained the length of BD, so what we do, if we take twice of BD, that's going to give us the length BC. So this will be equals to 2 times BD. So we have obtained the value of BD. This is square root of 3 over 2 times r. Square root of 3 over 2 times r. So the length BC comes out to be equals to square root of 3 times r. Fine. So that's fine. Now let's go to the altitude. So the altitude is nothing but the length AD. So here we have obtained that this length is r over 2. And OA, which is nothing but the radius of the circle, so that's r. So we have the full length AD, so that will be the sum of AO plus OD. Fine. So we have the length AD, which is the altitude, so that's AO, the radius, plus OD. Fine. So AO is r and OD is r over 2. So we get 3r over 2. So now we have the base and we have the altitude. So let's try to find out the area of the equilateral triangle. So area of equilateral triangle ABC. So that's nothing but half times the base times the altitude. So we get half multiplied to square root of 3 times r times 3 over 2 times r. So that gives us 3 times square root of 3 divided by 4 times r squared. So this is going to be the required area of the equilateral triangle. And coming to the value of r, we have already defined that r is given by square root of g squared plus f squared minus c. So we'll replace the value. So we get delta equals to 3 times square root of 3 over 4 multiplied to g squared plus f squared minus c. So this is going to be the area of a equilateral triangle that is inscribed within the circle whose general equation is given to us.